Hello, my name is Tarek. In the last lecture, we discussed about the Josephus problem and we saw what the problem is and what the appropriate solution will be. In today's lecture, we will implement the solution of this problem and we will discuss how this problem can be, how the solution can be implemented, and what strategy we need to implement. So before going into the coding details, first let's discuss its implementation strategy. So here is a here are eight nodes. We are implementing this problem with the help of a linked list, right? As we discussed in the last lecture, that the linked list is the appropriate data structure for the implementation of this problem. So we have eight nodes in a circular format, and we have two markers, two pointers, the previous and the marker pointer. The marker pointer will move one by one in the forward direction, and the previous pointer will follow the marker pointer. So the number of hops or number of steps that we want to jump will be 3, right? So initially both the marker will be pointing to the first element, and then the marker pointer will move one ahead, and the previous will point to the first element. Now the number of hops is 3, so the first element that will be deleted will be the 4. So from 1 to 2 is the first hop, now this is second hop, and the previous will follow the marker, so the previous will point to the 2, and this is the third hop. Marker will point to the fourth element and previous will point to the third element. Now this is, keep in mind, we are discussing the solution strategy here, right? So why we are doing this, I'll just explain you. Now we will delete the fourth element, the fourth node, as per the Joseph's problem. So the fourth node is out, and then let's just think that these two nodes are standing at this position. The marker is pointing to the fourth, and the previous is pointing to the third. So after deleting fourth node, third should point to the fifth, right? So in order to make this third node pointing to the fifth, we should have a reference of this node, so that we could then make or set its next pointer to the fifth. The previous pointer will give us the pointer to the third node or the previous node, and the marker is there to delete the node and to shift the marker to the fifth one. So the code would be something like previous dot set next, right? And what we will say in this method, we will say marker dot get next, right? Is it? Let me put it here, and let me make it a bit. Okay, now I think this will be clear to you now, right? So what we are saying is marker dot set next, set its next element to marker dot get next. Right? Marker is there, and its next element is fifth. So we are changing its reference to the fifth element, and we will then delete this element and move this pointer or reference this pointer to the fifth one. So we will, after doing this, we will remove this and we will shift this pointer to the fifth one, right? Now again we will both the pointers are at the right position. This is the marker and this is the previous position of the marker, right? Now we will move the marker one number ahead, is pointing to fifth, and the previous will point towards the fifth, and marker will point towards the sixth. Now we need to jump 3 steps. This is first step, 5 to 6, 6 to 7, 7 to 8. So now, now, so the marker then will point after making 3 hops. It will be pointing towards 8th element, and previous will point towards 7th element. So now we need to delete this. So when we will delete this, 7 will no more be pointing towards the 8. 7 should point towards the first element, and marker then will delete this node and will point towards the first. So previous dot set next, set the next node of this element to the marker dot get next. Marker is standing here and its next is 1. So we have set this pointer, the pointer of the 7th element. Now we don't need this 8th element anymore because we have set the reference, and then we'll move this pointer to the first and the previous will remain there, right? So in this way, the previous element, we are taking help from the previous pointer and the marker pointer. So we are using both the pointers, and with the help of these 2 pointers we are implementing the solution, right? So now let's see how the code will work. I have a package here, and I have already written this circular linked list class just for the sake of saving the time. And what is happening in this class, I'll show you. So let's write the solution class, and we'll say Josephus solution, right? And the Josephus solution, what we will first create circular linked list, CLN equals new circular linked list, right? And let's implement the constructor, and this constructor will take the number of elements that the user will pass. It can be 10, 8, 12, whatever, right? And whatever the number he'll pass, he will create a circular linked list. Integer I equals 0, I is less than size I plus plus, right? And we'll say cln dot insert. We are calling the method insert, and we are inserting the elements. So the first element inserted will be 0, but we want to start with the first one, like this. We want to start with the first element, with the first element, with the 1 element. So we will increment it by 1, right? And okay, we also need this size. So what we will say is integer total. We will say total is equal to 0. Let's say total, and here we will say total is equal to size, right? Okay, now let's implement the actual solution. Public void, and we will say start. When we start, we will say we will take number of hops. The number of hops we want for the solution. The number of jumps we can also say. Okay, so we will say cln dot set marker position to 1%. Okay, what this marker position is? This marker position will set the position of the marker to the element 1, right? Okay, so after this we will take help from while loop. While total is greater than 1. Okay, why greater than 1? Because we need the last element. We don't want to delete the last one, so we will loop it till the last one. For int I equals 0. This for is this loop is for the number of hops we want to take. I is less than equals to hops, and plus plus, and you'll say move move. Okay, what this move method is doing, I'll show you that. Okay, if we are starting with the element 0, then the number of hops, if 3, then it will go till 4, because 0, 1, 2, 3, right? Because we are using the equal operator. So we have two options: either we remove the equal or either we make it 1. So let's make this initialization of this integer variable to 1. Okay, now what this move method is doing, let's get into the move method. So here is a move method, and this move method is, this move method is what, let me show you the pointers. Here we have two pointers, the marker and the previous, right? The move method is just setting the previous to the marker and marker to the next one, right? Whenever we will call move, so what will happen, let me show you here. Let me undo all this. Okay, we have these two pointers, right? This is pointing to the first and this is pointing to the first. Then we say move, so move will, this is pointing to the second, right? And when we say move, the move will shift marker to the third one and this previous to the second one, right? And then, okay, after the number of hops we have completed, what we will do, we will delete, cll dot delete. What this delete method is doing, let's get into the delete method. Okay, now in the delete method, first we are checking is that empty or not. If not, then marker dot get item. We are taking the item of the marker. Why? Because we are then returning this to the calling method. Now previous dot set next is equal to marker dot get next, right? As you just saw, when we were standing at this position, the marker was at 4th and the previous pointer was at 3rd. So what we did, we set its next to the marker dot next. So marker dot get next, the previous dot set next. So we did the same thing here, and we will then move the marker to the next one and set the reference of the marker to the next one. So this is same as moving this to this one and setting the its current position is this. Okay, and when we will set its pointer, third pointer, so definitely it's no more pointing to the fourth one. Okay, so this is done, and we will now decrement the count minus, right? So we have to decrement the total. Okay, and in the last, just print out the cll dot to string. We are printing the circular list here, right? Now let's implement a class with the main method and call it execute, and execute, create a method of Josephus solution. We will say new Josephus solution, and size, let's say we are saying 8, and I'm saying solution sorry, where is the main method? So I forgot to do that, and let's copy this and paste into the main method Josephus solution, and I'm saying solution dot start, right? Number of hops is 3. Okay, and let's run this. Okay, so as we saw, the last person that will be standing and that will be alive was is the sixth one. The sixth person will be the last one, right? As we saw in our previous lecture here, and this is the sixth one. The all others have committed suicide, and this is the last one. Now let me do this with the 12, and the number of hops is 3. And let's run now. The first person will be the last one if there are 12 persons standing. So in this lecture we implemented your Josephus solution. We saw the implementation strategy and how can we solve this problem, and also I'll again emphasize on a very important point, that selection of the appropriate data structure is very important. So it's very crucial to have the knowledge of data structure. The more knowledge you have, the in-depth knowledge you have, you can solve complex problems smartly and very efficiently. Hope you have liked the video, and in the next lecture we will continue our discussion on the data structures. Thank you for watching.